All right, guys. Here's the video for the 2.5 notes. So we're going to look at compound inequalities and how to solve them. Um, don't freak out when you see that these are like a little bit more complicated. It's going to be the same thing again, over and over again. You're just going to be solving for your variable and then graphing your solutions. So don't worry about it too much. It's not going to be too bad. It's going to be okay. So some good warm-up problems here. Make sure you try those. Again, isolate the variable. Try to make a graph if you have to. Sound things out. When you read them, be careful about the way you read things. Look at the location of the variable. Those are all going to be important. Make sure you check them out. Get into the notes. So the graph of a compound inequality with an end is the intersection of the graphs. So you're going to see it's going to be like the middle section. Okay. And the union is going to be the compound inequality with or is the union. And so you're going to kind of see the graphs going to kind of spread out. You're going to see that here in a second. Okay. So the first one here, we're saying that x has to be greater than or equal to 2 and x has to be less than 5. So it's got to be both things, right? It's got to be greater than 2 and less than 5. So if I'm graphing this on my number line, I'm going to just start with the first guy. So I'm going to start with looking at this one. So greater than or equal to 2. So I'm going to put 2 on my number line. And I'm going to use a filled in dot because we can touch 2, right? Our value can be at 2. X can be equal to 2. And then I'm going to and then I'm going to look at the next guy, 5. Okay, so then put a 5 over here. This time we can be equal to it, so we put an open circle. Right, we're not going to touch 5. And now x has to be greater than this, greater than or equal to 2. So it's got to be this side of 2. But it's also got to be less than 5. So these guys are going to kind of meet, and you're going to have any value that's kind of in the middle in this section in here. Okay. So what are some possible solutions to this, right? 2 is a solution, obviously, because x can be equal to 2, greater than or equal to 2. 3 is a solution, right? Think about that one. 3, if I use 3, well, 3 is greater than or equal to 2, so that's correct. And 3 is also less than 5, right? So any number kind of in between here is going to be a valid solution. So now looking at the next one, here we have y is less than or equal to negative 2 or y is greater than 1, right? So here's that or statement. So we're at negative 2. And we're going to put a filled in dot because we can be equal to it. And y has to be less than this guy. So we're going to go over here. Right? Negative 3 is over here and negative 4, so on and so forth. Or y has to be greater than 1. We're not going to be equal to 1, so we're going to do an open dot. And then y's got to be greater than this. It's got to be bigger than it. So anything over here. Okay. So I want you to think about where the solutions are. Could you pick a number in here? I want you to think about that. I'm not going to answer that question. That's a good question for class. But think about if I picked a number in here, for example, 0. Is that a solution to this problem? Okay, I want you to think about that. Would 0 be a solution to this problem? Okay, so now here we want to translate the verbal phrase into an inequality and then graph it. So we want any real number that is less than negative 1 or greater than or equal to 4. Okay, so if I'm writing this out, I'm saying that x has to be less than 1 or x has to be greater than or equal to positive 4. So I'm putting this on the graph. You put negative 1 right here, 4 is over here. We can't be equal to negative 1, so I put an open circle. And x has to be less than this, so it's to the left. Or x can be equal to 4, so we put a filled in dot. And it can be greater than that, so everything to the right. And again, same question. Could I pick a number in between here? Would that be a valid solution? Think about that, right? Where would be your valid solutions to this problem? I'm going to skip this top one here because it's good practice for you guys. it's a good way of just practicing the words. But we'll kind of solve some compound inequalities. It's kind of be the bulk of the video here. So just like when you're solving regular equations, whatever you do to one side, you got to do to the other side. But here now we have three different chunks. Okay, so on this first problem, if I want to add 5 to isolate x, just like we normally would, right? Then I've got to add 5 to the 4, and I've got to add to the -7. I can't just do it to one or the other, right? I got to do it to everything to make everything equal. So when I solve this, you add 5 on both sides. So you add 5 to everything, right? To all the possible sides. Okay. So now this 5, this -5, and this +5 are going to cancel out. Quick reminder, those are called inverse operations. And -7 plus 5 is -2. Less than x. And then this is a +5. Okay. 4 plus 5 is 9. And so now if you're reading this, I forgot my sign. Less than 9. Okay, so if you're reading this, x has to be greater than -2, but less than 9. Right? If you're reading that out loud, x has to be greater than -2, but it has to be less than 9. So I'm going to put this on our number line. You have -2. You have 9. X has to be greater than this number, so we're going to use an open circle because we're not going to be equal to it on both of them. We got to be greater than -2, but we also have to be less than 9. So what could be a possible solution to that? So 0, for example, is 0 greater than -2? Yep. Is 0 less than 9? Yep. So it's going to be things in the middle. So then you can kind of connect these sections. And so anything in the middle of these, right, anything in this little portion right here on the number line is going to be a valid solution. And if you're reading this, you can read this a couple different ways, right? You can read this as -2 is less than x, which is less than 9. I read it as x is greater than -2, then x is less than 9. Okay? A couple different ways you can do the same thing. Okay, same thing on this one over here. Okay, I can subtract 4 on both sides, just like we would, or on all the sides, I should say. Right, things are going to cancel out. You got 6 less than or equal to 2y less than 20. Divide everything by 2. And you get 3 less than or equal to y less than 10. Another way of saying that is y's got to be greater than or equal to 3, but it has to be less than 10. So on the graph, you have 3 filled in dot because you can be equal to it. Open dot at 10 because you can't be equal to that one. Strictly less than. Y has to be greater than 3, so we went this side. But it also has to be less than 10, so we're going to connect it in the middle. Okay. And again, anything in this portion of the number line would be a valid solution. Okay. So for example, 5, right? 5 is greater than or equal to 3, but it's also less than 10, so that one works. Okay, last 2 questions on this video. So here we have just 2 separate inequalities, and we're going to solve each of them individually. Okay. So again, you're just solving like you normally would. I'm going to add 2. And you get 3x less than or equal to -9. Divide by 3. X is less than or equal to -3. Okay, so that's one solution. Or we have the other one, -18. And we don't have any negatives in front of our x's, but just think about what happens when you have a negative in front of this 2, for example. 2x is greater than -2. Divide by 2. X has to be greater than -1. Okay. So x has to be less than or equal to -3 or greater than -1. Okay. So we have -3 here. We have -1 over here. Open circle at -1. We got to be greater than that, so we're going to the right. close in circle and -3. We got to be less than that, so everything to the left. Okay? And again, think about where your valid solutions would be on this, right? There would be over here and over here. Last question. Mars has a maximum temperature of 27 degrees at the Celsius and a minimum temperature of -133 at the winter pole. Write a compound inequality describes the possible temperatures of Fahrenheit on Mars. Okay, so we know that the minimum temperature we can have is X has to be greater than -133, greater than or equal to -133. And we also know that X has to be less than or equal to 27, right? Because 27 is the maximum temperature, so it's got to be at most 27 or at least -133. So here's -133. Here's 27. Okay. And so Mars can take any temperature kind of in this range. So now it says here, give 3 possible temperatures, right? So anything in between here, so like 10 degrees Celsius, 5 degrees, 0 degrees Celsius, all of them would work. Okay. But I want you to think about how many solutions are there in this chunk? That's like a little challenge question for you to think about. So if I'm going from here to here, how many solutions are going to be in that chunk? That'd be a good question for you to think about. But that's the end of this video on compound inequalities. As always, guys, if you have questions, please let us know. We are here to help. But if not, have a great rest of your day, everybody, and we'll see you soon.